Now that we've understood how this branch and bound algorithm would work, let's think about the amount of work we had to do. For this simple problem, integer programming problem with two variables, where the variables could not take a value any greater than 3, it took us LP0 plus 6 other LPs, that is a total of 7 LPs to solve this very simple problem. So you can well imagine that if you had 10 variables, 20 variables, 30 variables, whether they were binary or integers, this is going to get quite difficult to solve. So therefore, though we have an algorithm, the branch and bound algorithm, it can take a large amount of time to give you a solution. It's quite possible that even a 20 variable problem takes several hours to solve. So therefore then, in practice, there are a few things that one can do to terminate a bit early. For example, let's say you pick a tolerance value. You say, if my upper bound minus the lower bound as a ratio of the upper bound is less than the tolerance value, then I will stop. So let's say I take this to be 1% or 0.5% or 2%. It could make a large difference in the total amount of time you would take. Because many a times we actually do have the candidate solution in hand, which is optimal, but we are spending a lot of time around the tree trying to prove that it is the optimal solution by closing all other nodes as being inferior to the one we have in hand. So that is one thing we could do. We could also ask the software package that would implement the branch and bound to stop after it has obtained maybe 3 solutions, 10 solutions, 5 solutions, whatever you wish, some k number of solutions. And look at those solutions, see if that works for us. Or we could stop once a certain amount of time has elapsed. So let's say I have only 8 hours to solve this, then I solve this for 8 hours and see what solution I get. Or specify a lower bound if a feasible solution is available at the beginning. And that could reduce the computational time as well, because now you can imagine, since you already have a lower bound, I could look around the tree and fathom the nodes which are not promising me anything better than what I already have in hand. And finally, even if after doing all these, taking all these steps, it is just taking too long for your problem to solve, you could use what are called heuristics. So heuristics essentially are different from algorithms in the sense that they construct a solution using certain rules. And therefore, they will terminate in a certain predetermined number of steps, which means then again that in a certain amount of time, you're sure that it will terminate. Many software packages that you may use would use heuristics, and therefore it's good to be aware that what you have in hand when you're using the software package may not be an optimal solution because it's not using the algorithm, but a heuristic.